Okay, so I am back with another video, and today I will be continuing the Calculus 2 playlist, and I am going to get started now with integration by parts. Integration by parts is pretty simple. I'll be covering the other integration techniques as we go, but today I'm going to be covering this example, and I'm going to go ahead and get started with this. So this is integration by parts, or IBP, as known by many. So okay, for this particular example, we can actually go ahead and rewrite this integral. We can go ahead and write this as ln x. Oops, I'm thinking about n for some reason. X to the negative 3. X to the negative 3 because it is on the denominator. Dx. Now, with integration by parts, there is a format, or I don't really want to call it a formula, but it is a formula in a way. And the way it is, let me go ahead and show it to you. Let me present it to you. So it is integral of u dv is equal to uv minus the integral of v du. This right here is the format that we must follow, and we will derive our u and v from here, from our original problem. So now let's go ahead and continue. We can go ahead and set u. This is kind of similar to u substitution, but a little bit more. It's not as elementary as the u sub. So I'm going to go ahead and set u equal to ln of x. And now I am going to do du, which is the derivative of ln x, which is just 1 over x dx. So now I also need to set my dv, and my dv, I'm going to select it to be x to the negative 3, and v is just the integration of x to the negative 3, and in this case v is just equal to negative 1/2 x to the negative 2. And this is pretty much all we need now to go ahead and advance through our problem. So now we are going to be utilizing this formula right here to go ahead and fill in the gaps. Now, as you can tell, I already laid out all the components that I needed for this problem. And also, this is a very efficient method that I recommend. It's just one of those where it's just like trial and error. Try it out. You could try it out with multiple integrals, but sometimes other methods are just going to be a lot better than others. So that's why I'm going to present the other techniques later on other videos. So now let me go ahead and continue with this problem. I'm going to go ahead and fill in this part right here of the formula. So now let me set my u. But in this case, since I have v, I'm going to go ahead and write v first, just for it'll look better. It's just to keep things neat. So let me go ahead and write this as negative 1/2 x to the negative 2. And now we have and I'm going to go ahead and write ln x. And now go ahead and write this. Write the second part. However, as you can tell, we need to write v. We have a negative 1/2. So therefore, I can actually just go ahead and write this as a plus, as a positive. So negative and a negative equals a positive, right? So, and actually I'll keep the 1/2 outside. I am going to rewrite that integral, and I'm going to put v in du. So now I have x to the negative 2 du have 1 over x. And this can actually be rewritten as dx as well. So now we already have our first part. And the good thing is that this is just one of those integrals that doesn't keep on going, because I am going to do an example in another video where the integration by parts just keeps on going, and in those types you just have to end up having to apply another method in which using reduction formulas are going to come in clutch. I was about to say clutch, but they're going to come in handy. So yeah, that's what we have. So now let's go ahead and integrate this second integral right here that we have. So now what we have is we can go ahead and rewrite this integral, this second part of the integral as, let me go ahead and rewrite it over here. We can go ahead and rewrite this as x to a negative 3 dx. So now that's what we have. It's just because we combined, or what we did here, we did a little manipulation of 1 over x, where this can be rewritten as x to the negative 1, and we combined this term and this term, therefore forming x to the negative 3. Now, I'm go ahead and rewrite this whole thing again. So negative 1/2 x to the negative 2 ln x plus 1/2 integral of x to the negative 3 dx. Now, I am going to go ahead and integrate x to the negative 3. The integral of x to the negative 3 is just negative 1/2 x to the negative 2. And that's what we have. That's the integral for that. So now we have that now. So we have ln x plus 1/2. Now remember, we need to multiply this, right? So we'll have negative 1/2 x to the negative 2. So now what's going to happen here is that we are going to have, these are going to multiply. So now we are going to have negative 1/4 because we're multiplying those fractions. Sorry. So now we have minus 1/4 x to the negative 2 plus c. And now this right here is the final answer, or final product. Thank you for watching.